In this section, we will cover edit checks and testing. Edit checks selected for use on a study are fully tested for each and every scheduled time point, both with a do not fire scenario and a fire scenario. Let's look at an example of a single edit check on a dummy study. This study has two treatment arms, Arm A and Arm B. It also has two protocol versions with different sampling schedules, with 4 different schedules in total. The TrackREX team will map all these schedules into the TrackREX tool. Let's say each schedule has an expectation of 32 sample draws. This results in 128 individual sampling time points. In turn, each of these schedules will require 2 test subjects, one to cause the edit checks to fire and another that never causes the edit checks to fire. So 8 dummy subjects overall. With each dummy subject testing 32 sampling time points, it means 256 test cases are created in order to fully test a single edit check. For general lab sample reconciliation, for example, PK or biomarker, the TrackREX team has identified 13 key edit checks. Non-lab reconciliation, such as ECGs, the TrackREX team has identified 10 key edit checks. In our example, there is a requirement to test 13 edit checks. Now remember, each of these edit checks required 8 dummy subjects and 256 test cases. This equates to 104 dummy subjects and 3,328 test cases. This will, inevitably, lead to some questions. Let's examine some of these now.
How on earth can you create 3,328 test cases? In EDC, it's time-consuming enough just to create a handful of test cases.
Our TrackREX team first creates fully clean test subjects for each schedule. A special code then creates test cases from the clean data. It does this by altering clean test data to make an edit check fire or not fire. It does this for each and every time point. Unlike the manual testing of other systems, such as EDC, it then becomes possible to test 100% of all theoretical schedule time points. The testing in TrackREX far exceeds most other UAT practices.
Wait. So, test cases are created programmatically? A program created data that then has programmed edit checks run over it? A program running over another program? Without a human, how can you be sure a program created test cases accurately? And using code, it cannot be creating test cases simulating real-world scenarios, can it?
Protocols, schedules, different analyte types across multiple therapeutic areas can be extremely varied in nature. However, the same sets of programming code can always be used simply because very little data is actually required in CRF to vendor reconciliation. And this little data, once inside the TrackREX program, is then inside a very highly controlled environment. This enables the edit checks to understand how to create test cases with predictable outcomes. The code also interjects a random element using built-in random functions with no 2 test subjects ever alike.
Okay. This still isn't entirely clear. But anyway, the most important thing for me is to know that this method of full-scale testing was accurate. How can I document this testing actually occurred, and in a way I understand?
The TrackREX team builds dummy studies for each new implementation. And at each new introduced schedule, should there be a protocol amendment, the dummy study outputs are provided back to clients. Let's look at this further. When setting up TrackREX to have oversight of a new vendor reconciliation task, the TrackREX team maps the schedules of a study. The team also assesses source data variable naming. These elements are then plugged into the already pre-built TrackREX tool. Thanks to the TrackREX tool being a pre-existing solution, a dummy study is soon created to include all edit check test cases and outcomes. The complete dummy study is returned to the client as a flat XLSX file. We cannot comment on a client's internal processes, but it is advised the returned file is stored in the study's TMF. Let's look at this returned file to understand more. The return dummy test study file starts with a cover worksheet. This is a table of contents with hyperlinks. We have a raw data validation section showing a summary of the dummy data that was used. This was covered in the TrackREX introductory video. As a reminder, let's click one of the hyperlinks. It provides a summary of raw data that was fed into the TrackREX program. It lists the raw data, then how the raw data was converted to become TrackREX readable in format. Derived data which lists specific effective attributes based on the date of a record, such as effective protocol, as well as stipulating if a record was destined for the report or not, and, if so, what row is the record associated with in the user output. In effect, this lists the journey an item of data went on as the TrackREX program ran, whilst each item of data can always be referenced back to the source system, such as EDC or vendor transfers. In this case, however, this is the dummy data that was created to test our study. Now we return to the cover worksheet. The next section provides a summary of the tested edit checks. We also have links to the user output and metrics. They are covered in the TrackREX introductory video. We are interested in the contents of the edit check test evidence worksheets. Each edit check tested has its own worksheet. Let's click on one. We are brought to a worksheet that begins with the dummy subject ID, then the edit check ID, and then the purpose of the edit check. Next columns provide a summary of the dummy data created. This data is also in the validation worksheets presented just a moment ago. We then come to a section detailing the expectations and outcome of the testing. Here, it is explained if a test case should result in an edit check to fire or not. Then, if so, what is the cause? We then detail the result, explaining where in the user output the fired edit check is and if the test case passed or failed. You can see both of these columns have hyperlinks to both the test data and the user output. Let's click on the user output hyperlink. We are brought directly to the user output row, which contains the edit check that fired, proving the test case did indeed result in the edit check firing. Returning to the test evidence worksheet, we can also click on a hyperlink taking us directly to the raw data in question. As you can see, not only is test evidence thoroughly provided, it is also made to be user-friendly and interactive. The ability to hyperlink to the raw data that, by design, caused the edit check to fire can be very useful. For example, if a colleague still has doubts about the reliability of the tool or accuracy of testing, they know exactly what field of dummy data to correct. They could also comment on this in the user output, and then send the changes back to the TrackREX team. We can refresh and prove the effectiveness of both the tool and how the edit checks were tested. In conclusion, all edit checks are tested for all time points. All edit checks are tested at each and every new implementation. That goes above and beyond other testing, such as standard EDC edit check packages that may only be tested once, but deployed continuously across multiple studies. Documented proof of testing is made available to clients for filing based on client internal processes. Clients will be able to clearly see how test data was suitably created to test each edit check. Clients with any remaining doubt are free to edit the dummy data to test cases even further and under their own terms. For example, simulating a correction of data, or to change clean data to cause an edit check to fire. A client will see their own test cases represented in refreshed output. This concludes our presentation on edit check testing and validation. Thank you for watching, and please do not hesitate to get in touch.